Right, so continuous distributions is what we've been looking at. How do we find expected value, variance, etc., for a continuous distribution? So x now is a random variable, but a continuous random variable. So the expected value now will be the integral from minus infinity to infinity of x, function x. So it's similar to the discrete one. Remember, it was the sum of all of them, but xpx, well, really when you think about it, that's exactly the same. You're summing up all of them, so you're going from minus infinity to infinity. It still turns out that the expected value of x will be the average or the mean of the distribution. So here we go. We've got a proposed model here of quarterly salary. X is measured in thousands of dollars paid to salespeople in a large company, and it's given by this probability density function. And it starts at 16 for x. By looking at the mean and the median, describe the distribution of the salaries in this particular company. So we find the median integral from 16 to m of x to the minus 7 on 2. That's going to equal a half. So add 1 to the power over the power, subbing in, and eventually we get that the median is 21.112. But remember, that's in thousands of dollars. So the median quarterly salary is $21,112. The average then will be x times the function. So x times x to the minus 7 on 2, going from 16 to, well, in this case, it's going off to infinity. Well, of course, you can't sub infinity in. So the reality is we're looking at the limit as x approaches infinity. And, well, it's a negative exponential. So we know that, well, that's going to come down to be 0 at the other end. So really, it's just when we substitute in the 16, and we end up with an average of 26.667. So the average salary is 26,667. So the median is on the left-hand side of the average. So in other words, most of the data is below the average. Now you may recall that that's called positive skewed. Right, variance, exactly the same now. It'll be the expected value of x squared minus what we found to be the average squared. But now our formula for expected value of x squared will be the integral from minus infinity to infinity of x squared times the function x, the probability density function. So let's find the standard deviation. To do that, we have to find the variance. So it'll be that integral minus what we found the average to be, which was 80 on 3. And eventually, 568.889. To find the deviation, we find the square root of that. So 23.851. So our standard deviation, 23,851. So remember, that standard deviation tells you about the spread. So the smaller and smaller the deviation, the more the data is clustered around the average. There's a graph of that actual distribution. And I've put a line in where the median ended up and where the mean. And I suppose in big corporations, yeah, that's pretty typical. A lot of people getting the low wages, and then you get the very few up the top getting quite high wages. 16C.